This problem says express the sum as a rational function. So this one, we have to create sums or a combination of sums for this sum here, or series. Okay, so notice this first one is positive, and the next one that's positive is 3 over, and then 3 over from that one. So I'm always looking for patterns when I see these problems. So that's a 3 that it's jumping. So if I look at the other pair, I can think of them in the same way. So this one, I could say every third one is negative from the second one. And from the third one, I can say every third one is also negative. So originally, I can write this as 3 sums. Now again, I might find a fancier way to do it, but I try to keep it as easy as I can. So if I look at those, the first one I'm looking at is x plus x to the 4th plus x to the 7th. So not only are they every third one from each other, but the powers also are the first power, the 4th power, the 7th power. They're 3 away as well. So if I'm just looking at that sum there, and if I kept doing this, the next one would be x to the 10th, okay, and then so on. Okay, so now keep in mind, I'm pulling every third one here. So this sum would be actually it would be 1, and this would be from x to the 3n. I could make it from 0, and then that means I would have to add 1 here, and that's okay. But that's what it would be. That would be the sum of that first piece. Now I'm going to grab a different color now. Now we're going to talk about the next piece here. So that's going to be these here. So that's x squared. Oops, not that one. X to the 5th. And then the next one would be here, and that would be x to the 8th. So this is a similar series. So if I wrote all those out, I would end up getting, and I will write them out just so you can see them together here. Negative x squared minus x to the 5th minus x to the 8th, dot, dot, dot. So that sum is going to be a negative, and I'll just put the negative out front. And this is jumping 3 every time too. So that's going to be 3n. Now remember here, I'm starting at 0, so I need that to be a squared first. So I would say plus 2. Okay, now I'm going to do the third one here. Now the third one is going to be these here. So there's the third, and then the 6th, and then the next one, so on and so forth. So that's also going to be a negative. So that's going to be a negative x cubed minus x to the 6th minus x to the 9th minus and so on. So that sum is going to be x, and that's also jumping to the 3n. Now again, I'm starting at 0 here, so this is going to have to be a plus 3. Okay, now I have all 3 of these that equal the sum. So what I would say now is I would say this equals, and then that first sum so then when I put them all together, this is what I end up with. Now I found the sums. I'm not done yet, but I'm pretty close. Because when we think of the series that we know, we get this. And these series are close to it that we see here. All 3 of these are. So they're off by these plus 1, plus 2, and plus 3. So that's what we'll have to kind of algebraically move around a little bit now. So in order to do that, notice what we end up with here. So now notice this series here, n equals 0 to infinity. I can call this x to the 3n times x. I can call the second one the sum n equals 0 to infinity, x to the 3n times x squared. And for the third one, I can call the sum n equals 0, to infinity of x to the 3n times x cubed. And then what I can do from all of those is I can just pull those out of all three of them. Now I pulled them out of each of the sums. Now notice this, if this was like a number 1, that was a number 2, and that was a number 3, notice everything in here are the same for all of these. So in essence, I could call that like my variable x or something like that. So then that would mean I could say that x minus x squared minus x cubed of the n equals 0 to infinity of x to the 3n. So I could say I just have that many of them. So this would be my sum, my series. Now knowing my series now, I know now that this series is equal to, and now I'm thinking of the rational function, that here I'm going to have x minus x squared minus x cubed, and this in here is going to be 1 over, and then this is going to be 1 minus x cubed, because I think of it this way. This is really x cubed to the n. So this would give me this as my answer. And to make this look a little nicer, I'm going to get x minus x squared minus x cubed all over 1 minus x cubed. So there's our final answer for this problem.